Let's see some more applications of prime numbers. We have this really awesome concept in math called the fundamental theorem of arithmetic. And that means that what it basically says, I can give you any one of our natural numbers. Natural numbers are just a fancy way of saying the numbers that start with 1 and go to infinity. So any of these, we can take any number that exists. They all work all the way up to the millions and billions. And we can write it as a product. Product means multiplication of prime numbers. The really cool thing about this is even if we start different, we're all going to get the same answer. So we can have different ways to come to the same answer. So you're not wrong if you do something different than I do. We all come back around in the end. To do this, we are going to do what's called the prime factorization. So the answer to this fundamental theorem of arithmetic is the prime factorization. So let's look at one. I'm going to make a factor tree for 300. Factor trees are super useful for a lot of different things. This happens to be one of them. So I'm going to think of two numbers that we can multiply together to get 300. Doesn't matter which two you think of. This is the cool thing. You can think of one that's different from me, and we're going to get the same answer at the end. So we have these different paths. Let's just say I'll go with the maybe not as obvious one. I'll do 2 and 150. A lot of people might have done 3 and 100. Doesn't matter. You do yours, come back at the end, and we're going to get the same answer. 2's prime, so I'm going to leave that one. 150 is not. I could say 150. I'll just keep with my 2's. I might say that's 2 times 75. Again, you could use 15 times 10. Doesn't matter. I'm going to keep breaking down any composite number that I have until only the things that are at the end of these branches, these stems, are prime numbers. So if you notice, I've got these numbers prime. So I'm going to write these as a product. Remember, that's multiplication of these primes. So there are 2 2's. So that's 2 squared. There's 1 3 and 2 5's. So I'm going to write that as 5 squared. The exponents there just say that I'm doing more than one multiplication. 2 times 2 is 2 squared. 5 times 5 is 5 squared. So that is going to be my answer. I'm going to leave it just like this. You can check yourself with these. If you type that in your calculator, you're going to get out the answer 300. The order technically doesn't matter because the order that we multiply things in does not matter. Let's see, 7 times 3 is the same thing as 3 times 7. They're both 21. So the order technically doesn't matter the way that you type them in or write them out. Let me do one more. So 1,750. I see this ends in 0, so I know it's divisible by 10. Well, neither one of these are prime, so I need to keep going, breaking them down into products of primes. So keep going until and think about what things that multiply together, and the ultimate goal is to end up with prime numbers. Let's see, 175, I know that divides 5. And then 35 is 5 times 7. So let's see, I've got a 2. I've got 1, 2, 3 5's. So that's 5 cubed. And I've got this 7 right here. And again, I could type that in my calculator and type that out. I'm going to get 1,750. And the order of the multiplication does not matter. So if you have 2 times 7 times 5 cubed, that is also correct. All right, I've got one down here for you to try. I want you to pause the video and give this prime factorization a try. Let's see how you did. This number, I'm just going to think about numbers I might multiply together to get the answer of 14,553. And I did not know. I just checked in my calculator and I divided 14,553 by 3, because that's a prime number. And it gave me a nice answer of 4,851. Again, I don't know what multiplies together to give me 4,851. So I thought, I'm going to try some prime numbers. So I divided this by 3. And again, I got 1,617. And I just kept going. These numbers that I don't know anything off the top of my head, I just keep checking prime numbers. When I got down to 539, I checked 3. It didn't work. So I didn't check 5 because it doesn't end in a 5 or 0. Then check 7. So keep checking prime numbers because this is a prime factorization. 11 did work. All right, now I've got my prime numbers. I see 3 3s, so that's 3 cubed, 2 7s, so 7 squared, and 11 for the prime factorization.